A very good afternoon. Once again, I welcome all the participants for the session 4 of this 6-day FDP program. And today we have with us, Mr. sorry. Today we have with us Mr. Manikanda Bharat, who is a marine geologist at Gavico Private Limited. Prior that, he was an exploration geologist at Geo Exploration and Mining Solutions, and he has done his MSc in Applied Geology from Anna University and BSc Geology from Manonmaniam Sundaranar University, Tirunelveli. Sir has a wide knowledge in this area. Sir, we are happy to have you here among us.
Thank you, ma'am. Thank you for the introduction. Can I start the presentation, ma'am?
Yes, sir, we can start it. 1 minute, I'll make you as the co-host.
Yes.
Yes, sir. Can you try to share your screen, sir?
Yes, yes. 1 minute.
Yes.
I hope the screen is visible. Yes, ma'am.
Yes, sir. It is visible.
Yes, thank you.
Can
Thank you.
you go to presentation mode, sir?
Yes. Is it okay now, ma'am?
Yes, sir. Perfect. Please go ahead, sir. Thank you.
Yes, yes. Thank you. Thank you for the introduction, ma'am. Good afternoon, faculties and professionals and students. I thank the management for this opportunity. So the topic given is advanced land survey methods and technology. So this is a topic given, but the FDP topic is recent advancements in geotechnical engineering. So this advanced land survey methods and technology and how it is effective or useful in geotechnical engineering aspect. So we'll be discussing this for example, for a period of 53 slides. So I have two slides, two presentations. So one will be 53 slides and one will be 78. So don't worry, the most important things will be explained. So these things are mostly theory content, and we have also images. So this theory content I will explain within a span of 30 seconds or like so what is given in this. So if the PPT chat you can go through that. Mostly we'll be going through the images and I will be explaining the images. So for a period of 45 minutes or 50 minutes, so these two presentations will be covered. Then afterwards, I have two videos which we have recorded in our initial working days. So I can also share. I have a hyperlink video. So regarding RTK DGPS, how it will be operated, how it can be operated, how the points are obtained, and also regarding drone surveying, how the mapping will be done. So some half video will be available. So the last half an hour will be these two videos will be shared, and I will be explaining by pausing the videos. So this will be the presentation format. So I will just dive into the presentation. Okay. So advanced land survey methods and technology, how it is useful in geotechnical engineering. So survey methods go hand in hand with the geotechnical engineering. Mostly for while if you are dealing with geotechnical, for example, the metro projects. So metro projects, if mostly in underground earthwork excavation, geotechnical engineers comes into play. So for those geotechnical engineers, surveying is most important. So they will be seeing the slope line, slope stability, and the retaining walls. So for all those things, surveying is essential. So in those aspects, what are the advanced survey methods available? I'm not going to touch even about total session because it has also become it is also becoming outdated, even the total session. So the recent trends are RTK DGPS survey, that is real-time kinematic digital global positioning system. So that one drone surveying, that is unmanned air vehicle, then lidar, then 3D laser scanning. Then GIS and remote sensing comes into place. That is, after doing all the surveys, it will be mapped or those points will be obtained. So after with these two slides, I will also be explaining how those values are obtained in the comma separator value CSV and in Google Earth Pro KML format, keyhole markup language, how it is obtained and how these data are input into the QGIS software, that is quantum GIS software, how it is obtained and how the projects are going on. So real time projects. Since it is an industry perspective, I will also explain regarding the industry perspective. So why this advanced land survey methods and technology? So improved precision and efficiency in geotechnical engineering. So the traditional method, the chain surveying, and all those surveying methods are traditional methods uh, to improve precision and efficiency. So for these aspects, we are going to land advanced land survey methods and technology. So that's a important thing. So what is land surveying and geotechnical engineering? So land surveying, measurement and mapping of land. So that is land surveying. So geotechnical engineering, so understanding of earth materials, that is soil and rock, to design foundations. So this is with respect to the definitions. So how the overview of land surveying and geotechnical engineering. So relationship and importance, how it is related, that is a land surveying and how it is related to geotechnical engineering. Explain. So these are interdependent disciplines. So why it is an interdependent discipline? So we are working together to ensure safe and efficient infrastructure development. Okay. So how it is important? Accurate terrain modeling and site investigations and foundation design. For example, accurate terrain modeling, you can see that land surveying, it provides precise topographical data and it is essential for geotechnical engineers to analyze site conditions like slope stability and drainage patterns. As I have already explained, for example, in mining area, mostly it will be subjected to slopes. And for example, in metro projects also, it will be subjected to slopes in underground. So to understand the slope stability, so land surveying methods will be employed. Then also site investigation, for example, boreholes, then trenches, then geophysical surveys. So for if you're doing boreholes, those boreholes can be marked in the DGPS survey, and those points can be obtained. That is a latitude, longitude, elevation of those boreholes can be obtained. That is how it is interrelated. Then foundation design. So survey data ensures proper alignment and positioning of foundations. So we'll be marking the foundation, right? So using the survey instrument, we can obtain the proper alignment and the positioning of foundations. So based on the geotechnical analysis of soil bearing capacity and settlement risk. So this is how it is related. Then landslides and slope stability. So lidar, light detection and ranging. So laser pulses will be passed. So using that, those laser pulses, it will get reflected on the surface of the earth, and then it will be going to the instrument. Then those values will be obtained. So the time taken to reach back to the instrument, so it will be used to calculate the distance and it will be used to calculate what type of soil is available. So something like that they will be using. So it will also be explained in the upcoming slides. So identifying unstable slopes and designing mitigation strategies. So these two or three slides I'll be explaining step by step in this theory content, because how we are in a position to know how this land surveying is is useful for geotechnical engineering. So this is how useful landslide and slope stability. Then earthwork and excavations. So using surveying, we can calculate the volume for earthworks. How we can calculate, for example, um, yeah, okay, so total station. So using total station, using RTK DGPS, we can just move the point. We can just move the rover or receiver unit. Then we can just keep the points and we can obtain the elevation of the surface of the earth. So for example, for 10 acres or 10 hectares of land, if you are going to use a DGPS survey, we can just move the rover units and we can place the rover units which is connected to the base station, and we can obtain the elevation value. So using those elevation value, we can find the ground level of those surfaces. So using the surfaces, we can find the cut and fill estimation. So like that, we can calculate the volume for earthwork. Then monitoring and maintenance. So surveying tools, example GNSS. So these are navigation, geo navigation satellite system. So this geo navigation satellite system is used in the RTK DTP survey. That is, we have a rover unit and receiver unit. So all these things will be explained in the upcoming slides. So how these tools are used for monitoring the soil movement and structural deformation. So how the soil is moved, for example, soil erosion, and the settlement also can be obtained. That's how. Then as already explained, it is for use in improved accuracy in subsurface investigations and limited precision in manual methods. So traditional surveying challenges in geotechnical and time-consuming process and difficulty in inaccessibility. So for example, land surveying and even total station also, we it may be difficult to reach the inaccessible areas. For example, if you're climbing a steep slope, okay, in a hilly region, using the total station if a survey goes, they may find difficulty in moving up the hill area. So during those situations, we can use a drone survey, that is unmanned air vehicle, which can be used to plot the latitude, longitude, and elevation of particular slopes. So using that, we can easily find out the data. And traditional methods are time-consuming process, whereas these modern advanced surveying methods are we can finish it in quick time. So that is with respect how the advanced survey methods, land survey methods, is in hand. It goes hand in hand with geotechnical. That is how it is related. Then the ground penetrating radar. So you can see here ground penetrating GPR. We call it as GPR survey. So when it is run, for example, Chennai metropolitan city, we have a water network and sewer network. That is, water network is for drinking water, sewer network is for drainage purpose. So through the pipeline, water will be supplied from the metro station, that is metro water department, to the households. Then from the households, drainage will be collected and it will be connected to the machine holes, and through that sewer network will be carried out, right? So for example, if there is a leakage in a particular pipeline, so using this ground penetrating radar, this will be just moved on the road. Okay, so to find where the pipeline is located. Okay, so for example, at a particular depth of 10 meter, 20 meter, like that. So this is how ground penetrating radar is. So it will send the signals and the time taken to reach. By this, we can identify where the exactly the pipe location is available. So this is with respect to drone surveying. So in agriculture sectors also, it can be used. So this is overlaying method. So you can see here drone surveying. It is operated by a person in the surface. You can see science, technology, and agriculture. Then all those data will be obtained and it will be processed. So that processing is the most important thing. Can see here, using the drone surveying, we can find out the latitude, longitude, and elevation of a building also, by just flying the drone around the building. So all these things can be done, and uh, we can also give the plan of the building, the existing building also. So for example, this one we involved in a project in Kannagi Nagar in Chennai. So you can see here the drone surveying. So why this project is done? For example, this Kannagi Nagar buildings have water tanks placed on it. So those, the elevation of water tanks, and the trees planted in the near the building, and the road elevation and the road alignment. So all those things can be easily mapped within a span of 2 hours. So Kannagi Nagar is a big area where residents are in the apartment type building. So all these things can be mapped using the drone. But before that, we have to get permission from the authorities. So there are also red zone, yellow zone, something like that. So we have to get permission if it is a red zone from the concerned authorities. So this is drone surveying. You can see here. So this is what we called as in normal surveying we call it benchmark or ground control point also. So this ground control point may have the established latitude, longitude, and elevation. That is for a period of 8 to 36 hours, the officials, the surveyors might have done static DGPS surveying, static surveying. So for a period of 8 to 36 hours, they would have done the survey, and they would have finalized the latitude, longitude, and elevation of this particular point and made it as a permanent benchmark. Okay, that is we call it as ground control point. Since we know this value, that is the value of this latitude, longitude, and elevation, we can just mark it in the base station, and those values can be fed into the rover. This is the rover. We call it a rover or receiver unit. Using this, we can send the satellite signals to the drone. Okay, so this how you can see here quarry or mining purpose also you can see. So this is the ground control points. So UAV drone data accompanied by high resolution imagery. So after obtaining the data, so this one is the high resolution image obtained. So which you have done in Kanagi Nagar related. So after obtaining this, we can see here the road. So the alignment of the road. So this is the width of the road. So we can just measure the width of the road also. You can see here trees are planted here. We can just also count the number of trees. So for example in a planned city, so we need the trees to be in a proper alignment in the road. So for these things can be monitored using this surveys. That is what I'm saying, trying to say. So in Kalakuchi district, so drone surveying is done. Then drone surveying Ajanta mining. So geotechnical engineers comes into play for mining. So we should excavate or we should do earthwork in mining uh, with a disciplined approach, right? So you can see using drone, we can just run the drone and we can survey. You can see here the angle of the slope. So if for over a period of time they will be doing drone, for example, 1 week after another week, then they will be obtaining the slope, that is the angle. So using that they will also be obtain the slope and they will find out the slope stability also. So you can see here the length here. Okay, so the length. So these are the images with respect to drone surveying. So advanced land survey technologies. Moving on from the drone surveying. So lidar. So lidar in geotechnical applications. So how lidar is useful? So lidar is light detection and ranging. So first, using this lidar, they will be sending some laser pulse. Okay, so you can see here lidar systems emit laser pulses that travel toward the ground and reflect back to the sensor. So the time it takes for the pulse to return it is used to calculate distances. Okay, so they will be sending some pulses, it will reflect back to the sensor, the time taken is used to calculate distance. That is a simple basic thing. So using this, they will be creating. 2 weeks per time or 1 year period of time. If you're going to a place and we're keeping that DGPS, we can obtain the elevation of that. So we can just compare the elevation 1 year before and 1 year after. Then we can find out the change in the elevation. Then we can come to a conclusion how whether it is settled or not. That structure is settled or not. That is how it is. It plays a major role in monitoring the settlement and the deformation. Then drones and UAV, so rapid aerial surveys of construction site and terrains, then real-time data integration. So, so how this drone is working? So that they will be equipping some sensors and cameras. So what are the cameras? RGB cameras, thermal cameras. Then lidar also will be employed in the drones. So those drones will be will have some more weight. Then photogrammetry systems will also be employed. So these cameras will capture the images and it will be transported in real time. Real time it will be transported to the base station and those things can be viewed from the site also. So UAVs fly over construction sites or terrains, capturing aerial images or lidar point clouds. So you can see here what are the things we can obtain: detailed imagery, elevation data, and subsurface condition. How this subsurface conditions can be obtained through thermal or lidar scanning? It can be obtained. Okay. So photogrammetry uses overlapping images to create detailed and georeference 3D models of the site. Then the obtained data, that is the data obtained from the drone, it will be processed. How it will be processed? So data collected by UAVs is transmitted to a base station. These base station things I will be showing images for a easy understanding in the upcoming slides. So data will be transmitted to the base station. In that base station it will be processed. How it will be processed? Using the softwares like Spitz 4D or Agisoft Metaset. You can see here the images I have shown, right? So this is how it will be processed. Okay. Then the necessary data, the elevation or the number of houses, number of water tanks, number of plants available, all those things can be. So using this software, they will be processing. Then real-time data transmission. So in real time, you when the drone is flying itself, we can see the real-time image from the ground surface. Then analysis and site monitoring. So we can get the borehole information, soil analysis and geophysical surveys. So the process then you can see here the data obtained from the drone can be overlaid with the existing geotechnical data. For example, you would have got the bore log report. So with that bore log report, we can use the process data. That what are the data such as borehole information. So the distance between the boreholes and the exact elevation of that borehole, exact latitude, longitude of that borehole, and the type of soil available. So all those things can be used. So it can be used to detect anomalies also. So, for example, rapid identification of soil instability or drainage issues can be assessed by comparing 3D models of the site over time. So, this comes into play site over time. That is what I'm explaining. For if you're doing drone survey today, and if you're doing drone survey in 1 week time, so this over a period of time, how it is changing. If that site is subjected to some slope instability, so over a period of time, we can identify how much it is affecting using these services. Looking for signs of deformation and erosion. So enhanced decision making part. So these things can be done within a short period of time. That is what they're saying. Then moving on to 3D laser scanning. This is also one advanced land survey methods. So this 3D laser scanning, so we can capture rock mass structures and subsurface data. This 3D laser scanning also employs lidar. So again and again, this lidar comes into play, light detection reading. So laser pulses will be sent to the required, that is the area of interest. Then laser pulses return reflects back to the sensors. The time taken is calculated. So using that, the distance will be calculated, and images also will be obtained. This is how it is working. So then after appending the images, point cloud will be created. That is the points will be marked. Then using that subsurface integration, you can see here other techniques like ground penetrating radar. I have already shown the image ground penetrating radar, right? So using that, we can see any pipeline network or any cables or any reinforce, for example, rebar reinforcements also might be there, right? So for example, if it is a foundation, All those things can be obtained. So borehole data to model hidden structures, then this data will be processed. Then moving on to GIS and remote sensing. All those data obtained from the drone and the 3D laser scanning will be processed in softwares like Pix4D and Agisoft, right? Then in DGPS, we'll be obtaining some data. So those data can be marked in the GIS. All those things can be marked in the GIS. So this GIS is a geographical information system. Real-time point data will be collected in a format called KML, keyhole markup language, or CSV, comma separated value. That is similar to Excel sheet thing. So those values, those files can be imported into the software called QGIS and ArcGIS. Then using that point, line, and polygon can be plotted. Then we can give attributes to those point, line, and polygon. Then we can form it as a geodatabase, GDB. We call it as GDB, geodatabase. It can be used in future purpose for easy understanding where it is located. So sewer network in water networks, currently CMWSSB, Chennai Metro Water Sewage and Supply and Sewerage Board is mapping the water and sewer network for easy understanding. Wherever we are providing drainage system or the water network, they're mapping using RTK DGP survey. So all those things will be resized within 2025. So in future, if there is any leakage in particular um, house or in a particular street, so that can be easily identified. Since we, for example, in Google Map, we are going from from our home to Central Railway Station, we'll be just typing Central Railway Station, right? So likewise, the points obtained using the DGPS survey will be available with the Metro Department officials. Okay, so with attributes, for example, with attribute means in Madipakam region, for example, we can say Madipakam region in Chennai, Ramnagar, it is situated in Madipakam, Ramnagar 7th Street. If they will be having some points in Ramnagar 7th Street, if they click the point, easily they can navigate to that point using Google Maps. So those things can be obtained using this DGPS. That point will have a latitude, longitude, elevation. Okay, so that point will have some pipeline network. We need not excavate throughout that street. Only that particular point we can excavate, and we can just clear the issue, and you can just close it. So in future, mostly in streets, metro department officials will not excavate unnecessarily. Particular point can be excavated, and issues can be solved. So this is how GIS will become comes into play. Then remote sensing. So remote sensing, using remote sensing, you can see here satellites. So remote sensing satellites. So now the artificial intelligence is used. So you would have come across the open source software called Google Earth Engine. So okay, so Google Earth Engine, they are using Python and Python programming. So using those Python program, they are obtaining the satellite images, and those satellite images will be processed. And using those satellite images, we can also obtain the soil data sets. I will show the soil data sets also in upcoming slides. So with that soil data sets, we can see whether it is a clay region for 0 to 25 centimeter, 25 to 50 centimeter, then up to 150 centimeter, we can obtain the soil data sets. Throughout the world, we can obtain. That is with respect to the remote sensing. So after obtaining the soil data set, we can map, and it is also useful in the research purpose also. If you are writing a paper where you are working on clay soil, you can just map where it is located using this remote sensing satellites. Then it is integrated to GIS software, that is QGIS and ArcGIS. So you can see here soil maps, geological data, and climate data also can be used. Then layers like slope, elevation, land use, land cover also can be done. So for example, flood zones, landslide prone areas can also be marked. This is how it is related. Then applications of land surveying in geotechnical engineering. Slope, as I already said, slope stability analysis, LIDAR and GIS for identifying unstable zone. Then site investigation, foundation design, accurate terrain modeling, and borehole placement. Then this one is a day-to-day or surveys come across, that is earthwork volume calculation. So before constructing a building, they have to level the surface of that site, right? So it may have some uh, up and down, that is a slopes also. It may have slopes, so they are in a situation to identify the level of that slope, that is the crust and trough of the surface, right? So for calculating the earthwork, why we need to calculate earthwork? Cut and fill estimation. So how much we have to fill the earth and how much we have to cut the earth. For this also advanced surveying like RTK DGP surveys done, and drones also used. Okay. So then monitoring and mitigation of landslides. So real-time data from GNSS and remote sensing. So tunneling and underground construction, accurate 3D modeling of geological layers. So they will be tunneling, for example, in metro, they will be tunneling in underground. Then they can use the drone to pass specialized drones to pass through the tunnel, and they can see whatever is situated in the tunnel before after the use of that drone. Then using those images they can see where some reinforcements or where some steel structures can be employed. So without the entering of the human being into the tunnel, so for safety purpose the humans can stay away and the drones can be pass into the tunnel. So this is how done. Then smart geotechnical monitoring system. So integration of IoT sensors, Internet of Technology, and surveying technology. So sensors can be placed such as strain gauges, inclinometers, and piezometers to collect data on parameters like soil movement, stress, and groundwater level. So these strain gauges can be placed in a particular surface, and it can be, for example, if there is a movement in soil, or if a particular place is exposed to more stress, or if the groundwater level is increased, it will be notified to the sensors if a strain gauge is placed. Then using that, they can easily find out the values, right? So this is how these sensors transmit data wirelessly to centralized systems for analysis. Okay. So surveying technologies like GPS and LIDAR complement this by providing precise spatial and topographical measurements. So the integration enables continuous monitoring, early warning of potential hazards, and data-driven decision making. So these systems are widely used in infrastructure projects, example mining, landslide areas, to enhance safety, efficiency, and sustainability. So how it is done, it is explained in here. First, they will be deployed the IoT sensor, that is strain gauges, piezometers, and kilometers. Then they will be collecting the data. Then it will be transmitted through wireless. Then using those data, the surveying integration will be done. So using the GPS, localization, and LIDAR, accurate spatial context. Okay, so using that they will be plotting in the software. Then the data will be analyzed and it will be visualized also. Then alerts. So after visualizing, they will give alerts whether the soil is moved, whether the soil is eroded, or whether there is some settlement occurred. So whether the slope is has increased, whether the vertical steeps has increased. So all those things can be employed. So, so up to this, we have seen what are the advanced land survey methods, that is drone surveying, that UAV, unmanned aerial vehicle. Then RTK DGP survey I'll cover in the upcoming slides. Then we have gone through the LIDAR, light detection and ranging. Then 3D laser scanning also gone. Then GNSS, that is navigation satellite systems, that plays a major role in DGP survey. We have images also how it works. So if all these things are done to find out the slope stability, then the foundation marking, foundation layouts, then the soil movement, settlement of soil. So all these things in tunneling also it is done. So it is, this is how advanced land survey methods are useful in the geotechnical engineering. Most important 2 points is improved accuracy and efficiency in a shortest span of time. So this is how it is useful. Case studies. I have two case studies. I will just say where it is employed. You can see him, Oysand region in Norway. So for slope stability, so how the advanced surveying method is used in slope stabilization. Okay, so in Oysand region in Norway, this project focus on a man-made slope affected by freezing thawing cycles. Okay, so they have conducted some field and laboratory tests. Then they have undergone some numerical simulations to understand the slope stability factors. Okay, so they have employed techniques like fine filament modeling and geotechnical monitoring systems also. You can see here how this is done. So first they have employed geotechnical monitoring. Then they have gone to numerical modeling, then remote sensing. So how remote sensing is here comes our advanced land survey methods. Okay, so aerial survey using drone they have done, then laser scanning, they have sent some laser pulses. Okay, then the time taken for the laser pulses to reach back the sensor, using that they will be calculating distances, and they also capture the images. Okay, so using that they have mapped the critical slope areas. This was combined with ground measurements for cross validation. So they have also got the field data, laboratory tests and field data they have got. So those data and with the data obtained from the aerial survey and laser scanning, they have combined and they have come to a conclusion whether it is undergoing some instability. Using those things, they will be stabilizing the soil. So integration with early warning systems. So it has it done in the Oisen Norway region. Then moving on, Ecuador's Las Cabras Hill region. So here the slope stability was analyzed using geotechnical surveys and susceptibility mapping. So using that again, so susceptible mapping. So field data, they'll be going to field, they'll be collecting the data. Then using those data, it will be integrated to GIS to create a landslide susceptible map. So those data will be fed into a GIS using a geo database, and it can be mapped. So this map identified high risk zones and help prioritize stabilization efforts. So using this map, we can say where it is, where the high risk zones are available. Using that, it can be useful in future purposes for stabilization purpose also. Then advanced surveying tools collect a precise slope data. So again, aerial survey and the lidar scan. Then that is with respect to the slope stabilization. Okay, your successful use of advanced surveying in slope stabilization. That is one case study. So moving on with another case study, integration of GNSS and LIDAR in large scale infrastructure projects. So that large scale infrastructure project is high speed rail project in California. Okay, so I will explain the background of this. So the California high speed rail project, you can see here, it is the largest infrastructure initiative in United States. So it is a 520-mile network. Okay, so it involves large-scale earthworks, viaducts, tunnels, and station facilities. Okay, so underground they are constructing. So given that's underground and also on the surface, but it involves a large-scale earthwork. Okay, tunnels also doing it. So given the scale and technical challenges, precise mapping, alignment, and monitoring are essential to ensure the success of the project. Okay. So our objective, how this GNSS and LIDAR is employed. So objective is to enhance survey accuracy, streamline construction process, and ensure proper alignment for rail system. As I have already said, Chennai Metro also employing this advanced surveying uh, techniques. Okay, so some surveyors employ total station, some surveyors employ RTK DGP survey. So this RTK DGP survey, real time motion, when you are moving that rover in real time, it can give the latitude, longitude, and elevation. So using that, we can just mark the points, and we can also say the alignment, whether it is in straight line or whether it is it is moving in a curved line, something like that. We can say the project team integrated global navigation satellite system GNSS and light detection and ranging technologies. I have already explained global navigation satellite system and light detection and ranging. So this global navigation satellite system, using signals from the satellites, they can give data like latitude, longitude, and elevation. This light detection and ranging, they will send some laser pulses to the surface of the earth, to the area of our interest, where we want our data. Okay, those pulses reflect back to the sensor, and the time taken, using the time taken, they will calculate distance, and also they also capture images. Okay, so all those things have been explained. GNSS for real-time positioning, LIDAR for terrain mapping and monitoring, then data integration and workflow, real-time monitoring and quality. So all these things I have explained already. So what are the outcomes? With enhanced precision, they obtain data and improved efficiency. So by combining GNSS and LIDAR, so the project team was able to reduce the time spent on manual surveys, so minimizing errors and accelerating the construction process. Okay, that's the thing. Then cost saving also, the risk of rework was reduced and the need for costly on-site corrections was minimized. So this is one major important thing, that's the need for costly on-site corrections was minimized. For example, using these surveys, we can just identify where the risk is within a short period of time. So if we can identify that risk uh, within shorter duration, okay, so we can just correct on time, then we can move on with the consulting process. Then better decision making. So the ability to visualize the entire project in 3D. Okay, so in 3D, so that is you, for example, in aerial surveying, if you are just passing a drone into a tunnel, it will capture image, and those images can be visualized by the controller who is standing, that is a human being who is standing, and it can also be viewed by the geotechnician who will be standing distance. Okay, they can just see how the locations are available. So continuously monitor it in real time and provide project managers and engineers with a clearer understanding of progress and potential challenges. So the conclusion is the integration of GNSS and LIDAR played a critical role in success of California high-speed rail project. So it offers significant advantages in terms of precision, efficiency, and cost effectiveness. So this case demonstrates how modern geospatial technologies can be leveraged for large-scale infrastructure projects to enhance planning, execution, and monitoring process. So these are the two case studies I decided to discuss with you. Then moving on, benefits of advanced surveying and geotechnical. Again, enhanced precision and efficiency, reduction in cost and coordination. So these things will be repeated again and again. Why this land survey methods, that is advanced land survey methods, are employed in geotechnical engineering? Okay, enhanced precision and efficiency, reduction in cost and project timelines. Then the challenges and future prospects. So what there will be some challenges in this, right? High initial cost. That is, it is a one-time investment, but that one time will have some high initial cost. For example, a DGPS in Indian market goes around 6 lakhs. Okay, so that will be a one-time investment, but initial cost is high. Okay, so but the projects it undertakes will give sufficient return in a span of 1 year time. Then need for skilled operators. These DGPS need skilled operators. So those skilled operators are essential. With that technical perspective, they can obtain. For example, they have to feed the latitude, longitude, and the elevation of a existing data available into the base station. Okay, so it should be fed into that base station. So using that data, it will be transported to the signal to the satellites, and using those data, it will be obtained in the river. So they are in a position to they're in a position to have a sound technical knowledge also. So need for skilled operators. So labor costs will also be reasonably high. Okay. Then future trends, AI and machine learning integration. For example, artificial neural network. You can see you would have come across the word artificial neural network. Okay, so using neural networks, we can also predict the geotechnical soil data. Okay, so for example, there is a software called MATLAB. So geotechnical engineers in the field of geotechnical, people would have come across MATLAB software, Plaxis software also. So this MATLAB software, we can do artificial neural network, that is the new using the neural network. There is a tool called NN tool, neural networking tool. So using these tools, we can predict the geotechnical data. Okay, so but how it is predicted? For example, we have to feed already existing geotechnical data in a particular site. Okay, so in a particular site, for example, what are the geotechnical data? For example, liquid limit, plastic limit, sink air limit, those are the Atterberg limits. Then um, from the direct shear test, we'll be obtaining the CPI values, right? Position value and angle of internal section value. So those things. Then the use, for example, UCC test will be applying the compression value of the soil, right? Unconfined compression test. Those things can be also fit. Then for example, in the road payment, we will be doing CBR test, right? Subgrade CBR will be obtaining. So those things can also be fit. Okay, so using artificial neural network, we have to feed in the existing geotechnical data. After feeding in the existing geotechnical data, there will be some hidden layers. Okay, then they will be running some trial sets. For this data, they will be giving the results also, existing results also. Okay, so for this data, the results obtained is this. Okay, so in future, if a particular liquid limit or a plastic limit or sink air limit or the C pi value is changing like this, what will be the data for a particular site? So it will predict some value and it will give. Okay, it is also subjected to errors. Okay, for example, plus or minus 5. Okay, something like that. It's also subject to some errors. So that is with respect to AI and machine learning integration. and Google Earth engine also comes into play. So using the Python programming and JavaScript, they'll be putting some codes and they'll be obtaining the satellite images using that also. Then autonomous drones for subsurface surveys. So this autonomous drones runs on its own. Okay, so you for the subsurface surveys, we need not go into the subsurface. Also, it can just fly in a in a auto mode, then it can obtain data also. So these are the future trends available. So this is with respect to advanced land survey methods, how it is, how it can be efficiently used in geotechnical engineering. Okay, so these are the things I will wish to cover. So how this land survey methods are employed, that will be the next part of the presentation. Okay, so I will be covering RTK DGPS surveying and drone surveying. So these are the two advanced surveying currently currently in trend. Okay, so they are used current in trend. So how this article DGPS surveying is done, you would have come across this word, but how it is done. Okay, so for example in B civil engineering, in third year I think so, for second year or third year I think so, sir. Third year they'll be having some surveying camp. Okay, so they'll be using total session. I think in second year in surveying lab they'll have a total station as a demo exercise. I think. Okay. They will be reading the components and everything. But in survey camp, they will be using the total station to identify to for marking the slopes and contour mapping, something like that. Okay. So now the advancement in that is RTK DGPS survey, still global positioning system. Okay, so the total station is slowly fading away because of this evolution of DGPS and drone. Okay, so how the theodolites, dumpy level, all those things have faded away because of the arrival of total station. Now this DGPS, after this arrival of DGPS, after arrival of drone for surveying, after the arrival of lidar photogrammetry system. So this total station are slightly moving away, fading away due to the accuracy this DGPS gives. That is 1 centimeter to 3 centimeter accuracy of latitude longitude elevation. Okay, so this one moving on. So before up to this, I have discussed how the advanced land survey methods are useful in the geotechnical. So that's I think so that satisfies the topic of the FDP, that is recent advancements in geotechnical engineering, how surveying methods are employed in geotechnical engineering. Okay, how we can obtain the we can identify the slope instability, how we can identify the settlements. this data will be employed, will be fed into this controller. Then this rover will be connected to the controller. Since the controller is connected to the base station, the signals will be transferred from the rover to the controller to the base station. Okay, so how it is transferred? The data given from the rover will be transferred to the satellite, then it will be reaching the base station. Okay, similarly from the base station, the data will be sent to the satellite and it will be reaching the rover. Okay, so what are the data we can collect from this? Will be discussed in the upcoming slides. So base station, what is a base station? Known fixed position station that receives GPS signals and calculates corrections. Okay, so this one is what we call as tripod, and you can see this one is the base station. We have a known latitude longitude. You can see here there is a particular round shape structure. Okay, so this is what we call as ground control point. Okay, for example, Chennai metro water supply and sewerage board, you can see in every area there will be a metro water tank. So on the top of the metro water tank, or in the drainage, you can see metro water drainage building also. On the top of the drainage building, on top of the metro water tank, they have established some ground control points. So how this ground control point is established? For a period of 8 to 36 hours, they have done static surveying. That is, they, using this base station, they will send signals to the satellite. That is GNSS, Global Navigation Satellite System. They will send some signals to the satellite, and they will be obtaining the data for a particular point over a period of 8 to 36 hours. Okay, so after obtaining that value, it will be correcting. Okay, so for a particular second, the data will be correcting. Okay, so after a period of 36 hours, the exact latitude, longitude, and elevation will be fixed here. Okay, so that data will be given to the surveyors as a Excel sheet or as a keyhole markup language, that is KML format. Okay, if they click on that point, they can, for example, in Google Maps, as I already said, right, if they click on that point using the navigation route map, we can just reach that point using the Google Maps also. Okay, the data they will be giving is latitude, longitude, and elevation, XYZ. Okay, so that data will be fed, that is the base station. Then rover, a mobile unit that receives both the GPS signals and the correction data from the base station. So what is this correction data? When we are moving, the data will be transferred from the rover to the satellite to the base station, then again from base station to satellite to the rover. So real time the corrections will be done, the latitude, longitude, elevation, the corrections will be done, then we can obtain the data. So corrections are broadcast over various communication methods such as radio, cellular, or satellite. Okay, so this one is the most important thing: radio, cellular, and satellite. Okay, so what is cellular? Using SIM card also we can obtain the data. Okay, so for example, if you're using Airtel, Geo, Vodafone, VI, any SIM card, like how we are communicating through mobile phone, same thing we can use a SIM card also. Then radio, using the antenna, by radio signals also we can obtain the data. Okay. Then preparation. So objective definition. Define the survey's objective. For example, if you are going to find the cut and fill of a surface. Okay. That is, we are going to find out the elevation. We are just defining the objective, what we are going to do. Okay. Then equipment check. Ensure all DGPS equipment, that is the base rover units and communication devices, are in good working order. Then site recognition. First, we have to identify the survey site. Then we have to identify the potential obstructions and assess the environment. Then base station setup. Okay. So now these things are explained in the theory format. I will play this video for your easy understanding. Whatever said in this video is explained in this. You can see here the base station, rover, then transmission antenna. Okay, so initialization, article. So all these things will be explained that in that video. So final one is output, GIS integration. So the output will be getting in as a point cloud data, then it will be exported to the software, ArcGIS or QGIS or Google Earth Pro. Okay, so this one is the output in Google Earth Pro. Then moving on, drone surveying. I'll just complete this, then I will play the video. So drone surveying with real-time kinematic. Okay, so drone survey also employs RTK method. Okay, so for drone surveying and DGPS are come hand in hand. Okay, so DGPS also essential for drone surveying. Why? They will be geo-referencing a particular point using the DGPS. So using DGPS, a latitude, longitude, and elevation will be marked. Okay, so by using that point, the drone will be keeping it as a geo-reference point. After keeping it as a geo-reference point, it will be moving on for a area of our interest, and it will be collecting data. It will be collecting the images. Using those images and using that geo-reference point, we can just plot the area, our area of interest with latitude, longitude, and elevation. Okay, so it integrates advanced GPS correction techniques with UAV, unmanned air vehicle technology, to enhance accuracy and efficiency of aerial surveys. I also have a video related to this. You can see here. This is a ground station or base station, that a tripod. Okay, so this one is the drone. Okay, then real time correction, you can see here, this one is a drone, these are the satellites. When the drone is flying, it will capture the images and it will transfer to the base station. On real time, the corrections will be done. What are the corrections which I'm saying is the corrections in the latitude, longitude, and elevation of a particular place. Okay, they, for example, a minimum of 4 or 5 satellites will be employed with this drone. Okay, they will be connected to this drone, then the data will be obtained. Okay, so I will play the videos. So before that, so far I have discussed the importance of advanced land survey methods in view of geotechnical. So how this land survey methods, advanced land survey methods are done, that is the procedure or the working principle in industry perspective. Okay, so RTK DGPS.
Hello everyone.
So this is my friend
In
Elil
this
Talapuri.
video,
They have he has
we
done
all
a
know that
video.
Earth is
Also
surrounded by man-made satellites
this,
as well as natural satellites.
whether the
Now
audio
the
is,
function of this man-made satellite is
whether you
Yes, sir.
can.
It's audible. Audible. Audible.
Yes,
Yes.
yes, yes. Okay, thank you. 22 minutes video, but I will just fast forward whenever necessary. Okay, whenever necessary, I will just pause and explain. Okay.
that we continuously send signals to the Earth. Earth is orbited by this network of artificial satellites, and the information contained by these signals are two informations. One is timing information and location information. Both these data will be continuously sent by the satellites. Next, we will see about the receivers. So, what is the function of receiver? The receiver will continuously receive the signals from at least 4 satellites, and with the help of these signals, the GPS receiver can calculate the exact position on Earth's surface. However, due to factors like atmospheric interference and satellite errors, there is a problem with accuracy. That's where DGPS comes in. DGPS means accuracy by providing correction signals from fixed base station to GPS receiver. However, for tasks requiring even higher precision, there is RTK DGPS. So, what is RTK DGPS? RTK means real-time kinematic, DGPS means differentials. Now, we will see the components of RTK DGPS in detail. RTK DGPS has 3 important components. One is
So this one is a tripod. This one is a tripod. So this one is a pole, and this one is a base station GNSS receiver, and this one is the controller which is
base
holding.
as well as rover receiver.
So this one is a
This is
rover.
just like a
Okay.
mobile phone. You can see here, you can make calls, you can insert SIM cards, we have a camera as well. All the features in the mobile phone will be available in this controller. So in this device, the base station plays a critical role as the reference point for the entire system. Now we will see the components of this base station very detailedly. The base station consists of a GNSS receiver. Now this is called as the GNSS receiver. It locates at the heart of the base station, and it is a high precision GNSS receiver. This receiver continuously tracks signals from GPS, GLONASS, Galileo, or other satellite constellations to determine its own precious position. Next, we have this antenna. Now, this one is called as the antenna. A high quality antenna is very important for optimal reception of satellite signals. So we can see the bottom of the base station. It consists of a tripod here, and you can see the tri-batch available here. And here it is the focus lens for centering, and you can see the level screws for here. Then you can see the split levels, so which is used for centering and leveling. So at the bottom of the tripod, you can see the accessory for centering purpose. There are many models in RTK DCPS like Trimble, but today we are going to see this Krypton model. To switch on this base station, you have to long press on this power button. You can see here a green light. So the green light represents battery. The device is switched on, and we have a Bluetooth connectivity. And for taking the points, this first option is the one which helps to identify that whether we are receiving the satellite signal or not. You keenly watch that once switching on the power button, after some 1 minute, this satellite option will appear in green color. You can see the green color blinking option, which means we are receiving the satellite signal. And one more important information is that a base station should be always placed at a clear, open skied place. Why? Because then only you can easily get the satellite signal properly. So the first step is we have to connect this controller with the base station. So you can see here this controller, just switching on the power button here available. So just I'm moving on. So you can see here there is an app named Nuwa, Nuwa. So this app is also available in the Google Play Store. You can download it in your mobile phone also, and you can use it as a controller in your mobile phone also. So I'm just opening this Nuwa app here. Just we can. So this Nuwa app has four icons here. You can see the first one is project menu. In that project menu, you can see here project, CRS, that is coordinate reference system, code, point, line, road, and export and import facilities also available here. Then the settings tab, cloud settings, and more. So moving on to next icon, it is the device menu. So you can see in the device menu, you can see connect option is available, data terminal, base station is available. You can connect with the rover, then NMEA output, device, tab, and more facilities also available here. Then moving on to the survey tab, survey menu. So survey option is available, points takeout, lines takeout, static survey, site calibration, survey configuration, base shift, roads takeout, surface takeout, then CADs takeout, that is CADs takeout, then more options available. Then moving on to a tools icon, tools menu, area perimeter, azimuth distance. So these things can be done. Then offset point, rotation point, 2 point intersection, 4 point intersection angle, earthwork, angular bisector, grid to ground, grid to ground, line segmentation, points average, then parameters, then more facilities are available. Before creating any survey operation, we need to create a new project. For creating a new project, click on this project option, and we have an option called new. Select this new, and it will ask you for the project's name. You can enter the project name. I will type here as EPA, and the creator name will give it as EBC. By default, it will update the creation date, and we have the coordinate system and all the other information. Just click OK. Now a new project will be created. Now a new project is created named as CTA. If you want to open a previously worked project, you can see here in the options, the previously worked option will be available. Now we have successfully created a project called as ETA. We will make changes to the coordinate reference system if needed. Click this CRS. CRS means
So this one is an important thing before doing the survey, coordinate reference system. So WGS 84, using this coordinate reference system only will be obtaining data. For Tamil Nadu region, WGS 84 44 not. Okay, that is EPSG 32644. That is a code name. EPSG is European Petroleum Survey Group. So they have given some values for this. Though using those data, it will receive signals from the satellite if this coordinate reference system is fed.
coordinate reference system, and WGS 1984, which stands for World Geodetic System. If you want to make changes, click this edit option. So currently we are
As you can see here, projection, that is UTM, Universal Transverse Measure. Then zone is 44, hemisphere is north. So 44 north is with respect to Tamil Nadu,
in Chennai, so the zone
Chennai.
is 44 north. If you are in some other location, based upon the location, you can change the zone and the hemisphere. Now we are going to connect this controller with the base station. For doing this, you can click on this device option and click this connect. You can see the device type, name of the device which is Oscar, and connect type options. You can either connect with the help of USB or else Bluetooth. Now we are going to connect by Bluetooth, and this is the name of the receiver, number of the receiver. The serial number is displayed here. Now we are going to connect this. Click connect. You can see here the device has started to connect and it is successfully connected. In this base station, the Bluetooth signal is on, so both this base station as well as this controller is now connected. You can see here the Bluetooth light is in green color, which represents both these devices are connected. Okay, so far we have seen how the base has been connected. So this controller and the base has been connected successfully. Then we are going to connect the controller with the rover unit. So for that, you can see after connecting successfully, you can see an icon called the Bluetooth is not connected. You can just now connect the controller with the Bluetooth. So you just given the serial number of the rover unit, just click on connect.
So it is
It is
similar to
currently
connecting
connected.
Bluetooth
So you can
devices
see
through mobile.
the Bluetooth is also connected with the rover unit. So similar to the base unit, the rover unit is also connected with the controller. So then we are going to say that this portion is the rover unit. So just click on the rover. You can see the status, ping status. Okay. So just do that. Now just give connect and see it. Okay. So far we have connected the controller and the rover unit to Bluetooth connection. So you can see how it is going to. You can see that 305 serial number is
the rover unit serial number. So we have connected this controller with the rover unit. Then we have to configure this rover unit with the controller. So just click on the rover. You can see these values are available. So this TCS, those are connected to the SIM card or the network. Okay. So now we are going to connect to the radio. Just click on the radio, internal radio. Then give detail. Just select detail. You can see these values are available. So you can see the protocol also. So all these are default values. Just click on OK. Then just click on start. So you can see the rover is configured successfully with this controller. So it is evident here. You can see that up arrow, upside arrow and down arrow is blinking in green color, and at the left side you can see the point is fixed. So using this, you can start the project. So we have configured the rover successfully with the controller. So then we are moving on to the project. So you can see we can fix the points now. Before that, we have to fix the height of the rover unit. So you can see the height of the rover unit. So this is a rover unit. So it is mounted on a pole. You can see the pole height is 2 meters. So the rover is mounted on the pole at the height from 2 meter distance. So mostly 2 meter is fixed. So it can also be varied according to the land conditions. So 2 meter. So the antenna height. So this rover unit has an antenna here. So this height should be fixed based on the pole. So this is, you can put 2 meters. 2.0. So the antenna height has been inscribed as 2 meters. So just click on the new project, select new, and just click to, and just okay. So new project is created. And see the new project is created here. Now click on survey. We are going to survey. So in this survey, just click on the survey. So we are going to see the points. Okay, so before placing the point, we are going to see the rover unit split level. You can see here the split level. So when the split level plays at the center, you can see at the left side it shows in green color. So if the split level is moved, you can see it is showing in red color. So the person whoever is carrying the rover unit should ensure that the split level bubble is placed at the center. So once the person with controller sees the green color signal, then they can click on the location. So after clicking on the location, you can see we have obtained the values of northeast and the height is 1.917 meters. So this height is from the mean sea level. So you can see here the base station is placed here, and from the base station you can see the rover unit is placed here, and the split level has been maintained at the center, and using that a point has been fixed. So this base station height is subtracted and this rover unit height is subtracted. That is antenna height is already input. So those things are subtracted from the ground station point wherever it is available. Then it is given this value. This is 1.9717 meter, which is from the mean sea level. So just click on OK. So a point has been added. So you can see the person is moving this rover unit to another point. to another point. Then he has ensured that the split level bubble is placed at the center. So once you see it is blinking green, just click on the location. You can see another point is placed. That point is at a height of 1.9223 meters from the main sea level. The northing is value is also available. Just click on OK. Another point, that is point 2 has been created. So similarly, you can see the area can be covered and the areas can be obtained for the. So next third point is placed. Just click on the location once you see the green signal. The point is obtained, just click on OK. The third point is also placed. The person has moved the signal on the splitter. You can see point has been obtained, that is a point 4. It's a very simple process. So like this, point has been obtained. You can see the person has completed the area. Just a rectangular area we have created for example. So the 4 points has been noted. So to see the values of the 4 points, just click on survey. You can see that text option is available. Just click on that. Then you can see points option is available at the bottom left corner. Just click on that. You can see the values of the points are available. Base station is available. Then point 1, 2, 3, 4 detail is available. Then the northing easting values of the base station and the 4 points are available. You can see the height also available. So the base station we have given WGS 1984, so it is representing minus 89.9820. Other 4 values we have given in northing easting height, that is the UTM values, universal transverse Mercator value. So it is represented as like that. Then you can see the latitude longitude values also available here. Height values according to WGS 1984 also available. And the collection time is also available. So there is one more option above the location point. You can see edit option available. Just click on the edit option. So you can see polyline, polygon, square, diagonal, square center, rectangle, rectangle center, circle, so available. You can just click on polygon. Just you can give the line name and code. Just click on OK. These things can also be done here. So we have seen the values of 4 different points on the base station. We can export those values. You can see here. Just click on export. So the first one is coordinate export, then other export is available. So in this coordinate export, you can see, just click on all the values available. Just click on detail. Yes, you need all values. Just click on all the values. Yes, so all those values are selected. Then the format we are going to select is name, code, and not PC height. Then the file name, you can give any file name which you want. You can see the storage part is available. Just click on export. So before that, I will explain the other export. You can see here one. So you can see you can also select the file format which you want. So the already existing file format is KML. You can also see shapefile. This point coordinates can be also exported as a shapefile also SHP. Then all the file formats DXF, HTML, XML. So these are the file formats available. So we are going to take it in the KML file. You can also export it as a shapefile and you can use it for the ArcGIS, Vue.js or Google Earth Engine purpose. Now I am going to export it as KML. Just say the file name and just click on export. I will show this other export. Just click on export. Click on share. You can see these are the options available. So so you can see the Bluetooth. If this controller is connected with the internet, you can also mail. You can save to drive. Mostly will be sharing with nearby share. So you can connect this one with the other phone or other devices available. So then this exporter file can be used for mapping purposes and other utilities.
Yes. So after exporting the data, we have said in this video, right? those data can be exported in the format of CSV, comma separated value, and KML, keyhole markup language, right? So this is like CSV. It is similar to a Excel format. You can see here. So in that video, they are explained as a point 1, 2, 3, 4, right? So that points can be named also. So it is when we are dealing in a particular project in CMWSSB Metro Water Drainage Project. So we are just they have given the machine hole name. Okay, so we are just mark the machine hole name first. Okay, so we can see MH, that is machine hole. So previously it is called as manhole. Now we are calling it as a machine hole. Then the northing easting height values are obtained. Okay, so these northing easting height values are obtained in the CSV, that is comma separator value format. So this is all obtained from the controller using that. Okay, so this is CSV comma separator value. So this data can also be imported to the QJS and ArcGIS software. Or you can see this one is the Google Earth Pro. Okay, this is also open source software. It is available in your Google Play Store and also available in desktop. Also you can download. Okay, so that data which we are exported in KML, right, in the video you would have seen. So that data is obtained like this. Okay, so it has a latitude, longitude, and elevation, right? So while opening that KML value, I'll just open and show. You can see I have just clicked on a KML. Okay, you can see. Yes. So these are the points obtained from that KML. Okay. So this one is sewer network data. For example, if I click on this point, okay, you can see here that point name is 1911. That is the machine hole name. So it is HSC, means house service connection. Okay, that is the HSC, house service connection. You can also see here 143. That is a house service connection. Then 930 MH machine hole. Okay, so these data are obtained here. And using this Google Earth Pro, we can just zoom in and we can just go to that particular. Okay, so this one is supported by Google. They will be running some vehicles through all our areas and they will be giving some data. So most people would have come across this. Then exit street view. Okay, so in the street view we cannot find these points. After exiting the street view we can find the points located. Okay, so this is how the points which we have surveyed can be exported. Okay, so now we have exported the point and we have viewed it in CSV, comma separated value format, and KML, Google Earth Pro. That KML is can be opened in Google Earth Pro. Okay, so now we have seen. So it should be processed now. We are in a position to obtain the final results, right? So you can see here, this one is QJS, Quantum JS. Most people would have come across this. So here I have to just drag this and then just click on this add layers. Okay, so if I click on this add layers, you can see here these are the layers: release points, your machine hole, house service connection, heads up here. So these are the layers. So how these layers are obtained? Just I'm going to view panels in browser. So CMWSSB has given some geo database. So that geo, using that geo database, you have to just click on the geo database and you can see here CO network is available. Okay, so in that we have to just click and drag here machine hole. Okay, house service connection, all those things. So after dragging that only, you can see here we can just close this. Okay, on also open treatment. Yes. Yes. So this is a base station. This is a overhead tank. and this is a base station point. So this is the point from the KML. Okay, so we can just click on the machine hole. This is a point. So just click on this manual distracing tool and just click on this point. So by clicking on this point, that database contains attributes filling. So all these attributes are non-spatial data. For example, machine hole size, MH metal of consistent brick, RCC brick. So these are the attributes. So likewise, we can fill those values. Okay, so the data is obtained and these attributes are filled. Okay, so you can see here. So this one is with respect to some sewer network we have been involved in. You can see here this one is a machine hole. Okay, so just this one is a sewer main pipeline. So these are the houses you can see. Yes, you can see here. These are the houses. So in real time, we would have carried a rover unit and the pipeline up to which the house service connection is given. We have that end of that house service will be the starting of the house service. That is the mouth of that house service connection. We will just keep a point, and in the controller, we will just click on that. Okay, so that point is obtained. That is transferred to the QGIS software. From here, house service connection will be joined to the machine node. So which means drainage is connected from this point to machine node. Okay. So it also has a flow direction employed. So it will be decided by the authorities, that is the construction people. So from where to where it is flowing. For example, this is a head shaft sieve. This is a head man machine node. From here, it will be flowed. So all these things will be connected to a sewage supply, sewerage collection point. That is a building. So, for example, you can see this. Here the drainage collection system will be available. It will be connected to that. Okay, so it is one example how RTK DGPS survey is employed in the sewer network. Likewise, it can also be employed in the identification of slope instability and the settlement, and mostly it plays a major role in cut and fill estimation. That is calculating of volume of earthwork. So this is how QGIS software comes into play. Then we shall be moving on to drone survey. One more video. With that, I will conclude. Okay. So this one is the last one. Some few 10 minutes. So how drone surveying is employed in real time. So this is surveying a lake. So with our fellow colleagues, we have surveyed.
We can use it. Drones are not only for wedding photography. We can use it for advanced surveying as well.
So you can see here, this white and red one is the ground control point. Okay.
Hello guys, today we are at Nathambete Lake in Kanjipuram area, and we are going to do an advanced survey for this Nathambete Lake using drones and RTK DGPS. The major problems faced by this lake is that they are dumping the municipal solid waste at the corners of this Nathambete Lake. So we are going to do a detailed survey for this lake using RTK DGPS as well as drones and identify the boundary of this Nathambete Lake, depth of the Nathambete Lake, as well as how this lake is being contaminated and how the aquatic life is getting disturbed because of this municipal solid waste. All these things we are going to detailedly survey and present in this video. And our team is here. They are initially fitting the base station with the help of RTK DGPS. Our captain is fixing the base station. This is our base station for this advanced surveying, and we have fixed our GNSS receiver. And in between this lake, there is a train track, and you can see a train rolling over the track. Main problem segment is solid waste management. They are dumping the waste, solid waste in lake environment. Within the lake itself, they are dumping the solid waste. You can see the top corner. There are huge deposit of solid waste. They are dumping in interior of the lake. After that, there is many wetland areas there because of the many birds.
So usually for drone survey, they will be using some paints, white color paints, just for the visibility from the aerial view for the drone.
Other side of this lake, other side boundary, and marching towards the exact boundary of the water body. And placing the ground control point, one more ground control point over here for
So minimum 3 to 4 ground control points will be placed, covering the boundary of the our area of interest. Here our area of interest is a lake.
we are inside this lake. In the third GCP ground control point is located inside this lake. And currently we are inside the lake at the other corner. And this soil appears to be a paleo of Palar River, paleo channel of lake, but it's showing the sand is looking for river sand. It may be. It looks like a river sand, bro. It may be Palar River paleo channel. So we can study about the climate also. For drone surveying, we are going to use this Mavic 3.
So before the drone is flight, we have to establish our ground control points, and using the DGPS, we have to mark the boundary of the lake. So how the RTK DGPS done, we have explained in the previous video. We are just marking the boundary of the lake. That is the latitude, longitude, and elevation of the lake will be marked using the DGPS. Okay. So then we are moving on with the drone. So drone and RTK DGPS comes hand in hand.
DJI Mavic 3 or transmitter.
Transmitter.
Okay, this is transmitter. And this one battery. We have 4 sets of battery.
Okay.
This is RTK module.
RTK model.
RTK module.
RTK
For
model.
aerial surveying purpose, we are going to use this module. We can attain centimeter level precision through this module. Then finally, this is our drone, DJI Mavic 3. Propellers are there.
We are going to fix this propellers while flying. This is loudspeaker. Uh, we can broadcast our message directly through this drone in real-time basis. This is useful for crowd control monitoring, surveillance purpose. It is very helpful for police personnel. Okay. Actually, it has two cameras. One is wide angle camera, 20 megapixel. This one is telemetry camera, 12 megapixel. Okay, our team is ready with the drone surveying, pilot and co-pilot. The person in the orange here is main pilot and the green one is the co-pilot. நீங்க வந்து பிளான் கொடுத்துருவீங்க அதுக்கு ஏத்த மாதிரி ஆமா நம்ம லேப்ல பிளான் ஃளைட் பிளான் ரெடி பண்ணி
So this is what I call the real-time monitoring. So this one, the drone is flying and it can be viewed by the pilot. Okay, so he has mentioned the co-pilot, right? So the co-pilot can be a geotechnical also. So this one is with respect to lake. So with respect to mining, with respect to some underground, with respect to some earthwork in surface. Okay, so using the that inaccessible areas, right? Inaccessible areas, this drone can be flight and it can be viewed. The slopes can be identified, how the slopes are done. So the soil erosion can be also identified in the inaccessible areas also in real time.
டிரான்ஸ்மிட்டர்ல அப்லோட் பண்ணிடணும். ஓகே, இங்க இப்போ ஜஸ்ட் வந்து பாராமீட்டர்ஸ் மட்டும் செட் பண்ணி அதை எக்ஸிக்யூட் பண்ற வேலை மட்டும்தான். இந்த ஆப்ரேஷன்லாம் ஒன்றும் கிடையாது, ஆட்டோமேட்டிக்கலி நீங்க வந்து பிளானை கொடுத்துருவீங்க அதுக்கு ஏற்ற மாதிரி. ஆமா நம்ம லேப்ல பிளான் ஃளைட் பிளான் ரெடி பண்ணி டிரான்ஸ்மிட்டர்ல அப்லோட் பண்ணிடணும். ஓகே, இங்க இப்போ ஜஸ்ட் வந்து பாராமீட்டர்ஸ் மட்டும் செட் பண்ணி அதை எக்ஸிக்யூட் பண்ற வேலை மட்டும்தான். இந்த ஆப்ரேஷன்லாம் ஒன்றும் கிடையாது, ஆட்டோமேட்டிக்கா அதுவே ஆப்ரேட் ஆயிடும். ஆமா நம்ம எல்லாத்தையும் ஃபீட் பண்ணணும், அவ்வளோதான். இந்த ஃளைட் பிளான்ல எவ்வளோ ஆல்டிடியூட்ல பறக்கணும், எவ்வளோ ஓவர்லேப் இருக்கணும், எவ்வளோ ஜிஎஸ்டி இருக்கணும், டிவார்பிங் சொல்லிட்டு இருக்காது, பேராமீட்டர்ஸ் எல்லாமே நைட்டே ரெடி பண்ணி அதை அப்லோட் பண்ணிட்டேன். ஓகே, அதனால இப்போ ஜஸ்ட் டேக் ஆஃப் பண்ணால் போதும், ஆட்டோமேட்டிக்காக எல்லாமே அது பண்ணிடும். நம்ம அதை ரெடி பண்ணி அப்லோட் பண்ணுறது தான் நம்ம வேலை. கேஎம்எல் அப்லோட் பண்ணிட்டா அது ஆஸ் பர் த பிளான் போயிட்டு நமக்கு கொடுத்துரும், ஃபோட்டோஸ் கொடுத்துரும். அதுதான் கேஎம்எல் வந்து இப்போ நம்ம கஸ்டமர் ரெடி பண்ணாங்கன்னா அவங்களோட ரெக்யர்மெண்ட் எங்கே, அவங்களோட நீட் எங்கன்றதுக்கு கரெக்டாக அவங்க ரெடி பண்ணி கொடுத்துருவாங்க. அந்த டேட்டாவை நம்ம கலெக்ட் பண்ணி கொடுத்துடலாம். ஃபோட்டோஸ் வந்து ஃபோட்டோஸ் வந்து நம்ம ஃபிக்ஸ் பண்ணணும். ரெகுலர் இன்டர்வல்ஸ் இல்லை, நமக்கு எவ்வளோ தேவைன்ட்டு. இது சர்வே இன்டர்வல்ன்றதுனால இதில் வந்து நம்ம மினிமலாக வந்து 0.7 செகண்ட்ஸ்க்கு ஒரு பிக் எடுக்கிற மாதிரி ஃபிட் பண்ணிக்கலாம். ஓகே, இப்போ அப்படிதான் பண்ணியிருக்கேன் நான். கிரிட் ஒரு 5 மீட்டருக்கு ஒன்ஸ் அந்த மாதிரி எடுக்குமா, இல்லை வந்து டைமிங்க்கு தான் எடுக்குமா? ரெண்டுமே இருக்கு. டைம் பேஸ்டு பிக் எடுக்கிறது இருக்குது, டிஸ்டன்ஸ் பேஸ்டு இருக்குது. நான் வந்து டிஸ்டன்ஸ் பேஸ்டு பிக் எடுக்கிற மாதிரி செட் பண்ணியிருக்கேன். ஓகே, ஈக்குவல் இன்டர்வல்ல எடுக்கும். ஓகே, எடுக்கிற மாதிரி செட் பண்ணியிருக்கேன். ஓகே, ஈக்குவல் இன்டர்வல்ல எடுக்கும். ஓகே,
So this is the aerial image of that Nathampetti lake. Okay, so this is these are aerial images of surrounding.
4 பார்ட் மட்டும் பார்த்து இருக்கு, 4 லைன் மட்டும் போகும்.
Then it is successful.
ஒரு 80% இருக்குமாண்ணா, 90% கவரேஜ். 90 பண்ணணுமா? நீங்க பாத்தீங்களா? ஏன் சார்? ஏன் சும்மா போடுங்க, கொஞ்ச நேரம் ட்ரோன் வச்சுக்கி உள்ள.
So that is with respect to collecting data in real time. So that data will be processed. So that will be explained by fellow colleague Chanley Jabari in the form of lake frontal development and digital twin. So that is with respect to drone surveying and RTK DGPS survey. Okay, so that is the three Ds: DGPS, drone, and digital record creation. Okay, in the span of 2 minutes, I will just go to these are the data collection, DGPS survey, and data process. You can see primary ground control point nearby, SOABM. So this is how the data collected is overlaid. Okay, digital elevation, DEM models. Then you can see the geo database obtained. So these are the in common identity. Then DGPS survey, we have some set of plans. So you can see the map creation, point data and disk size data. So this one is a point data, that is Google Earth Pro your shown, right? This one is a disk size data, that is disk sizing in the software, QJS, ArcJS, something like those softwares. You can see here base is an establishment site using known point, the survey of India point. Okay, so you can see here 8 to 30 hours, 36 hours observation site to establishment of site benchmark. So the benchmark is established by 8 to 36 hours observation. That benchmark has latitude, longitude, and elevation. With respect to DGP surveying, I'm saying you can see a village boundary A and B stone values. So these are the boundary stone value marks. So this one is ground truthing. So what is ground truthing? So in from satellite we would have obtained some values, the elevation. Okay. So using this GGPS on the ground, we are cross verifying whether those values are correct or not. That is the ground truthing. Then FMB, field measurement book, and village map procurement. So these are geo-referencing and mapping. So you can see here, this is drone UAV photogrammetry technology. This is flight plan aerial triangulation. So this one is the aerial view. You can see here how it is processed. The software Pix 4D and Agisoft. Those are softwares in which the drone aerial images can be processed. So you can see the elevation also can be obtained. But for this RTK DGPS, it's also essential. So it should be it is used for geo-referencing. That is, a known point will be taken and the latitude, longitude, elevation. From that known point, another point will be fixed. Okay, so using that, the drone will be mapping those values. Animate smokes can also be done. So imagine it in an inaccessible hilly region where we are in a position to identify the slope instability, or we are in a position to construct a retaining wall. So in view of a geotechnical engineering point of view. So so far we have, with respect to geotechnical engineering, that is we are just involved in a project of earthwork volume calculation, that is cut and fill only. We have not moved on to further geotechnical investigation projects. So you can see here these are the ground control points available. This is a aerial view of this. Okay. So dealing a confirmation of village boundary. So this is boundary marking, village boundary marking. So these are the points you can see here. So with accuracy and precision, we can obtain these values to scan the village maps. So you can see here high resolution imagery using and so on, so on, all this one. So these are this size data. So you can see this is the attribute. by just clicking on that place, that is a polygon. You can just fill on. You can see this is a attribute, non-spatial data. So imagine it in a form of a borehole information. If you just click on a borehole point, you can just feed all the data of that borehole. Okay, so you would get in a bore log report, right? So all those data can be filled in this as an attribute also. The uh, depth of the layer, that is a soil depth of soil type, each soil type, at what depth it is available, the groundwater level, groundwater, all those things can be fed in this.
Sir, sorry to interrupt, sir. We are running past our schedule.
Okay, ma'am, I'll just conclude with this one, 30 seconds. So you can see the height of this building. Yes. So that's what I have wish to share with you guys. So thank you for the patient listening. With any doubts, you can ask. Thank you. Thank you
Thank
for
you, sir. Thank you so much for such an uh, elaborate and detailed, informative session. Now the forum is open to the participants. We can take a couple of discussion or questions.
Yes, in the chat box, Dr. Rajesh Khanna sir has asked that base station always plays building stock because it is yes, base station is always most of the times, 95% of the times, it is placed on the building top or the metro water tank, something like that. Yes.
So the
Any question?
videos are also there. Participants have asked, sir. Can you share the videos? You
Feedback.
can share it to me. I'll put it in the
Yes, yes,
WhatsApp.
ma'am. We have also uploaded in YouTube also. I just share the link of that those videos.
Yes, yes.
Any
Um,
any other questions you can ask?
I think there is no other questions, sir. So, once again, on behalf of Wiltech and Department of Civil Engineering, I'm extending my heartfelt thanks to Manikandan sir for such a very, very informative session. Thank you so much, sir.
Thank you, ma'am. Thank you for the opportunity. Thank you all.
Thank you.